This is another 2D rigid body equilibrium problem, and what this problem is asking us to do is determine the tension in this rope AB and determine the reaction forces at point C. And this joint right here is a pin joint. All right, so first step is to draw a free body diagram. Let's sketch out the rigid body approximately. Let's draw in our external forces. Those are the easiest ones to draw in. So 240 newtons, another 240 newtons, and then we have to deal with these reaction forces. Well, let's do this tension force first. When we cut the rope, what tension always points away. So if we cut the rope and we're looking at it from point B, tension is going to point away from point B. If we were looking at it from point A, tension is going to cut to point away from point A. But this up here is point B, so tension points away from point B. We'll call this tension AB. So this is some unknown. We still want to figure out what this angle right here is. So if we call this angle theta, then angle theta is going to be the inverse tangent of 0.24 divided by this distance over this distance, 0.18. We're just using right triangles. So let's put that in the calculator. All right, so if we take the inverse tangent of 0.24 divided by 0.18, we get that this is equal to 53.1 degrees. So right here, 53.1 degrees. All right, so that is our tension force. Our pin joint. Pin joints are going to have two different reaction forces. We're going to have one reaction force that goes in the Y direction. We're going to have one reaction force that goes in the X direction. So we'll call this CX and CY. Well, that means when I don't know what the reaction force is, I want to assume they're in the positive direction. That means I'm saying anything on this problem that's going to the right is positive and anything that's going up is positive. We don't need to do this, but it's good practice to get into so you don't start messing around with negative signs. So when you don't know a force, assume the force is positive. If you are incorrect with that assumption, all that means is when you solve for this force, it's going to have a negative sign and the force just actually acts in the opposite direction. No big deal. All right, so we have our free body diagram. The next thing we want to do, we want to sum forces in the X direction, and this is equal to 0. So first, let's take this TAB force. When we decompose this into X and Y components, they're both going to be, well, the X component is in this minus X direction. So we're going to have minus TAB times, well, we are opposite angles, so we're at sine. So the sine of 53.1. Okay, and then we have this CX, so plus CX. No other forces in the X direction, so that's equal to 0. Now we want to sum our forces. Leave a little room, but we want to sum our forces in the Y direction. So these are going to be equal to 0. Anything that's going up is going to be positive. TAB, when we decompose and we get this Y force, it's pointing downward. So we want to say minus TAB times the cosine of 53.1. Then we're going to have plus CY minus 240 minus 240 is equal to 0. That's the sum of the forces in the Y. So far, this has been easy. Now we want to take the sum of some moment about some point. There's really two good points to pick. One, we could pick this point right here, which is C. Another point that's interesting to pick would be to pick B. It does not matter what point you pick. I'm going to sum my moments about point B. I'm going to say counterclockwise is positive, but I encourage you to try this problem, summing your moments about point C. You are going to get the same answer. But if I sum my moments about point B, I don't need to deal with decomposing this force into X and Y components, and CY actually goes through that point. So It's just, in my opinion, a little bit easier, even though point C is going to be almost exactly the same. So if we sum our moments about point B, we said Cy doesn't exert a moment about point B because it goes through point B. TAB goes through point B. So the first force we need to figure out the moment about is Cx. Cx, if it rotates about point B in a counterclockwise manner, it's going to rotate head first, so it's going to be positive. So this perpendicular distance right here is going to be 0.18. All right. The next force is going to be this 240 Newton force. As we rotate 240 Newtons about point C, it rotates tail first. So this is going to be minus 240 times this perpendicular distance, which is 0.4 meters. And then this is going to be the same thing. It's going to rotate tail first. So it's going to be minus 240 times 0.4 plus 0.4 or 0.8 meters. And this is equal to 0. So now we can actually just solve for what Cx is. We are going to get minus 240 times 0.4, then minus 240 times 0.8, and then we are going to divide, we're going to bring it to the other side of the equation, so we can multiply that by a minus 1, and divide by 0.18. And here we get Cx is equal to 1,600 newtons. Okay. Now, we can actually use this to solve for our other unknown forces. When we use this to solve for our other unknown forces, we can bring Cx over here. Let's actually rewrite this now as TAB. Sine of 53.1 is equal to Cx. So this is going to be equal to, let's erase Cx and put 1,600 newtons. So let's divide this by 53, the sine of 53.1. And we get a tension force, which is equal to 2,000 newtons. Okay, and then we can solve for Cy. We can take this Cy and we can equal this to TAB times the cosine of 53.1 plus 240 plus 240. And we know what TAB is. TAB right here is going to be 2,000. So if we have 2,000 times the cosine of 53.1 plus 480, we get that Cy is equal to 480 newtons. Now, Cx is positive, so it is correct. It is pointing to the right. Cy is positive, so it was also a correct assumption that it is pointing upwards. And these are your answers. If this video was helpful, please consider subscribing to my channel and liking the video. It helps my videos get more visibility, and it helps people who may be struggling with the same topic find the videos easily.